One.
Hey everyone, this last video is going to start working with this idea that our periodic table is actually split up according to whether electrons are falling into S sublevels, P sublevels, D sublevels, or F sublevels. And we're going to start using that knowledge to write more specific electron configurations Schrodinger's way, instead of Bohr's way that just tells us how many total electrons we might find in a particular energy level. We're going to be giving those electrons more specific addresses. And to do that, what I've done is I've just taken this general framework where we have our S block with our 7 energy levels, P block with energy levels 2 through 7, D block 3 through 6, and F block 4 through 5 on our energy levels. And I've just translated that over to the periodic table that is in your reference tables. So I've got all of those different blocks highlighted with their corresponding energy levels next to them. So this notation means energy level 1 in the S block, energy level 2 in the S block. Over here, energy level 2 in the P block. Right here, energy level 3 in the D block. We're going to start using that notation to pinpoint down addresses of electrons that get built into all of these elements on the periodic table. So have this handy as you're working because it's going to be your guide as to how to write these electron configurations. So you'll see on the next page of your mini lesson notes, what we're going to start finding. My notes have these pink arrows that have been added to them. Don't let them stress you out right now. But they're telling us exactly how to read the periodic table. And guys, it just boils down to reading it like a book, from left to right and from top to bottom, right? So I'm going to start over here at hydrogen and read left to right, and move on to my next row, read left to right, move on to my next row, and read left to right. What you notice is I first run in to my 1s stuff, right? Energy level 1, S sublevel. And you'll see if I start approaching this on the diagonal, that's the first stuff that we run into on this diagram. All this diagram has done is taken every single energy level that I see and written out all my S's, all my P's, all my D's, and all my F's. So we'll keep working with that. Notice when I go down to the second energy level, first I run into my energy level 2 sublevel S section. And then if I move over to the right, the next thing that I run into is my 2 P's, energy level 2, sublevel P. This diagram tells me my 3s sublevel should be next, and sure enough, here it is on my periodic table when I go down a row. 3s, then 3p. My diagram tells me 4s should be next, and here it is. Energy level 4, sublevel S. My diagram tells me that I should run into 3D next, and sure enough, here it is. So what this diagram, it's often used as a crutch in like an advanced chemistry course or in an AP Chem course. All it's telling us is the order in which electrons like to be added as we move from element to element. Because you guys know that the atomic number represents the number of protons and also the number of electrons in an atom. So here, hydrogen's 1 electron. When I add 1 to that, I'm going to start building up off of my first electron and adding it into different regions of my periodic table. And we're going to take a look at that through examples, so don't stress you out if that sentence made no sense whatsoever, okay? This is called the Aufbau principle, where we build up, starting with our lowest energy sublevel, my 1s, energy level 1, sublevel S, and building up to higher energy levels. So as we move from left to right and then top to bottom, we're gaining more and more energy. So we're going to fill our bottom stuff first and then build up from there. So again, let's take a look at some examples so this doesn't sound so stressful, okay? So have your periodic table on hand, because I'm not going to use this crutch as much to try and get you used to reading your periodic table like a pro, okay? The first element I wanted to start with was helium. Helium, we know, has 2 electrons. And Bohr tells us that by just writing the electron configuration as 2. That tells me there's 1 energy level and it's got 2 electrons in it. Schrodinger says, give me more. Where are those 2 electrons? Are they in the S sublevel orbitals, or are they somewhere else? Well, looking on our periodic table, I know that helium really should be scooted over here. its first electron is going to fall into that first energy level, into an s orbital, sublevel, sorry. That second electron will also fall into my first energy level, into the s block. So I'm going to write that as sort of an address. These two electrons are found in the first energy level, in the s sublevel, and within this division, within the first energy level, s sublevel, helium has 2 electrons. So this tells me 3 things: which energy level the electron is in, what block is being filled. Is it an s sublevel block? Is it a p sublevel block? In this case, our only option was s because we're still in this green territory. And how many electrons we find within that particular region. So what you're going to notice is that these superscripts that we're starting to write are going to begin to correspond to these Bohr electron configurations. Let's take a look at another example. The more we do, the more natural this will start feeling. Beryllium is element number 4, so it's got 4 electrons. Bohr tells us 2 of those electrons are in the first energy level and 2 are in the second. Schrodinger is going to get more specific. Our first energy level electrons, we know, need to be in an s sublevel because that's our only option. So we're going to fill that s sublevel up with 1, 2 electrons. Then we're going to move in, because we're out of space in that first energy level, we're going to move to our second energy level. We run into our s sublevel first. We fill it with not 1, but 2 electrons, because beryllium still has those 2 electrons to go. So I'm going to show that there are 2 electrons in my second energy level by putting that 2 and associating with the s. And again, notice 2 electrons in the first energy level, that's the 2 over here. 2 electrons in my second energy level, that's the 2 over here. This is just a more specific address than Bohr was able to give us, and we're really going to see that in the next example. We're going to look at fluorine, element number 9. Bohr tells us that 2 electrons are in our first energy level and 7 are in our second. So let's take a look at that. I'm going to put in my first energy level both of those electrons into my s sublevel, 1s2. It's full. Move on to the next row. 2s2. I've filled up my s block. I don't have any more room for electrons in the second energy level in an s sublevel. I've got to move on to my p's. So I come over to this 2p zone, and I notice I don't need 1, not 2, not 3, not 4, but 5 electrons to go into that 2p level to bring me up to fluorine's box. So I've got 2p, and I needed to put 1, 2, 3, 4, 5 electrons sublevel in order to get up to a total of 2 plus 2 plus 5, 9 electrons. So that address is coming from 2 electrons in my first sublevel, 1s2, and 2 plus 5 electrons, both in my second sublevel, gives me 7. But what Schrodinger is telling me that Bohr didn't is that those 7 electrons are distributed into 2 different places. The s sublevel, which could hold 2 of them, and the p sublevel, which had to hold 5 extra to get to fluorine. So I'll walk through the next couple of examples in the next video because I'm running out of time on this free software. But see if you can't take a gander at what you think those Schrodinger electron configurations might be as we get more and more complex, as we run out of room in corresponding energy levels. So I'll make a 4th video so that you can look through those examples, because the more you work the problems, the easier these electron configurations become and the more powerful they are.